So looking at the function we looked at in the previous example, f of x equals x times e to the negative x squared over 2. Now on this half open, half closed domain, 0 less than x less than or equal to 2. The derivative is the same thing as before. Using the product rule, we get the following expression. So setting the derivative equal to 0 implies that 1 minus x squared equals 0, again because the exponential is not 0. Gives me that x equals plus or minus 1. So my critical points, now I definitely have 0 and 2, but I also get the value 1. Note, negative 1 is not in the domain. So it is not critical. Again, we only worry about these values. So 1 is good. 0 technically isn't in the domain, but based on what we discussed previously, we're going to count every endpoint, open or closed, as critical. So we've done step 1. Step 2, we simply make an x versus f of x table with the possible critical points, 0, 1, and 2. 0 plugs in as 0. 1 plugs in as e to the negative 1/2. And 2 plugs in as 2e to the negative 2. This, I believe, worked out to be 0.61. This works out to be 0.27 approximately. Step 3 says find the biggest and the smallest. Well, here's the biggest thing. Here's the smallest thing. So the oddity here is that there is a global maximum. But you don't actually get to this value because this was on an open endpoint. 0 is not technically there. So what step 4 says to do is make sure these points actually work. This point is in the domain, but since this one's not, we'd get really close to this, but we don't get it. So there is no global minimum here. Therefore, f has a global maximum at x equals 1, 1, e to the negative 1/2. Again, either way, reporting is going to be fine. And f has no global min. A quick sketch may illuminate this for you. The graph looks something like this, where I get a closed endpoint on the right side. This is at 2, 0.27. But the origin, technically, is a tiny hole. So you never get down to 0. So any point we would choose as being the lowest point, I get a little bit lower later on. But 0 is not in the function, so it can't actually be a global min.